welcome to workshop 2 of our ISS Ride-share. And I think, Mike, you mentioned earlier that you and Gino are putting together a custom payload on the prototype board. So if you wouldn't mind just repeating what you're looking at doing for everybody.
Sure. So to start, so the lab that I run here at Montana State, we build electronics hardware that we test on high altitude balloons. So what we're doing for the project is we've actually taken the CAD file for this proto board and we're building our own board, our own custom board that'll be the same exact footprint as this. And we have been having trouble coming up with what the right research question is to ask. And so the approach that we've decided to take is, we're going to have this unique opportunity on station to collect data. So let's collect as much data as we can. So we're putting as many passive sensors on our board as possible. So we have a gamma ray detector. We have some air quality sensors, accelerometer, gyroscope. We have a GPS receiver, maybe five or six different sensors, just trying to log as much data as we can. And then we have this data set, after the flight that we can look at. And for going years forward, we can have undergraduate students can formulate questions that they want to ask and do secondary analysis on this data set. So that's kind of our approach. And then, so I've got my student on here. Gino is the one that's actually doing the board design. So he may have some technical questions today just to make sure that what we're building is going to sort of play nicely with the rest of the system. So essentially, in the end, we'll have our board that we build. The ISP32 board will essentially plug into the bottom of it, and that'll be our system. So we're trying to get the first version of that built before Christmas, knowing that we'll have issues with the board and we'll have to do some redesign. Want to make sure all the edge connections come out correctly and that it connects with your hardware and plays nicely. So that's kind of where we're at, and that was what started the discussion of maybe you don't have to have the research question, but maybe you can collect a rich set of data and kind of figure out the questions later.
Absolutely. Um, Alex, we have some news for you.
Okay.
Today, your code and your selected X chips flew on the Phoenix rocket in
Awesome. I was
South
actually going to
Africa.
ask about that by the end.
Yes. So, yeah.
So,
So for Mike, Gino, and Ifriki, South Africa is developing launch capabilities. And so we have a team from the University of KwaZulu-Natal who are developing a vehicle. So it was a test flight today. And we were actually quite pleased. They achieved 12 kilometers in altitude. They were aiming for around 10 because there was a lot that they were looking to test as part of the process. The payload bay was meant to eject, which it did do. Um, uh, Unfortunately, the main parachute didn't deploy, and we had much heavier winds than were anticipated, and it flew out to sea. So unfortunately, we couldn't recover it. Not for lack of trying. There was a boat out there with a very experienced skipper, but they weren't able to recover it. But it did. It flew, and yeah, unfortunately, we weren't able to recover it. So
as I said to Don from Parklands, it's going to fly one way or the other because he was joking about the last one had blown up. So I said, no matter what, the code's going to fly. Whether we get it back or not's not the important part. The code flew.
it did.
That's great.
Yeah.
I mean that was great news, by the way. Got some messages about it, like, hey,
Yes.
this whole thing seems fancy, so essays on the map and all the things. So if you look carefully on the map, you will see essay, and if and now like you said, things are flying.
Yes.
Great achievement. Indeed, from a university project, fantastic.
Yeah. No, absolutely.
No, that's totally
Um,
awesome. So, well, not that we didn't
yeah.
recover it, but the fact that it launched is totally awesome.
Yes, yes, absolutely. So, Alex, thank you very much for that. Yeah, as you know, it all came down to the wire, but that was
Yep.
fine. You know,
I learned a
Bianca
tremendous
three.
amount.
Oh, good, great. Bianca 3D printed a housing for it and everything else, and did his own integration manual video, and we sent that off. So that was great, and I can see that we've been joined by Susan. Susan, hello, nice to see you again, as well as Mike Galvin. A few weeks ago, it was fantastic because I was able to meet Susan in person because she and I've, you know, been Zooming for quite some time. And oh, everybody's frozen. Does that mean I've frozen?
Not the greatest. Let's see. Are you
Okay.
back, Julie?
I'm back. That was very strange. My Zoom rebooted in the middle of the process. Right. But I was just mentioning that I met Susan for the first time in person a few weeks ago in Massachusetts, which was fantastic. Great. I think we should continue with our discussions. So, Mike Galvin, thank you very much for joining us. And I do have some news. I'm not sure. Some of you may think it's great news. Others of you are going to think that it's terrible news. We haven't been able to secure a launch provider for the high altitude balloon project late December, January, who can guarantee recovery for us. And so therefore, we've decided that we're not going to do the high altitude balloon project now. What we'll do is we will rather do some other experiments. And let me explain fully that decision. We had been chatting about Alex, Alex and 3 students from Parkland, so a total of 4 payloads. And they wrote the code to save the data to the SD card. And with the payload being lost today on that Phoenix launch, we actually have no results. So yes, it was great in terms of meeting deadlines, etc. But the thing is that the learning from the experience is extremely limited. Mike, you and Gino are putting together a custom payload. We do not want to have that situation where you fly that payload and that payload doesn't get recovered. We're not making any progress towards our goal for ISS unless we know that we can guarantee recovery. So, what I'm doing is I'm putting it out there to you, and I'm saying that, I mean, if you really feel that you want to do something, it's just that I don't have a provider who is going to guarantee recovery. We thought we were going to be able to use the provider that we used last year in Maine. Unfortunately, he is completely booked. He's actually traveling. He's volunteered for Engineers Without Borders, so he's going to be traveling. He's not able to assist us, and I haven't been able to find anybody else who can guarantee recovery of those payloads. So yeah, let me please get some feedback on that. Mark Galvin.
Um, I mean, I think I've given my feedback already, but I mean, we're a go for it for any provider, no matter how sketchy, because our payloads are totally replaceable. But
Okay.
if we defer, if there's other schools, if you don't have a critical mass of schools ready for the launch, I wonder if everybody would be happy to in exchange accept a pre-booking on, a future MaxIQ balloon launch.
Well,
Yeah, no,
certainly. Yeah, Mark. Yeah, sorry.
I was going to offer. I mean, my group here, we are a high altitude ballooning group. That's what we do. I I can't guarantee we'll get your payloads back.
Nobody can. Nobody can. Every high
Yeah,
altitude balloon launch is a roll of the dice.
it definitely is. We lost our first payload just this last month, but that's 1 in 5 years. That's pretty good. But it is something we could potentially do. We are in Montana and we're heading into, I mean, we're already in wintertime here, which does make wintertime recoveries pretty difficult. We've got some 10,000-foot mountains that surround us and some high snow levels. So recovery does get a little bit harder in the wintertime, but it is something we could potentially do if there were teams that wanted a flight. We could potentially do one from here.
Our
Yeah.
board is also, as soon as it arrives, assuming it is functioning, we are, I think it is not like a deal breaker if it is a risk of not recovering it, because we generally order multiple so that we can make multiple backups.
Yeah, we do when we order boards, we get 3 of everything. So we always have a flight board and would have a backup board. Yeah, so a loss of our payload would not be the end of the world.
Instead of a free release high altitude, what about it just at least for the learning portion and just testing flight hardware? What about a tethered balloon? Do we know someone or could we do a controlled tethered balloon at least to a couple thousand feet again to make sure everything's working and that we get to do that everything works the way that we want it to? I mean, that would be my only other thought. I mean, again, we're using just the straight sensors right now. I don't think we'll come up with anything custom. And even if we do, I'd follow the same process as Mike. We would order multiples for it to work. But then from the learning perspective of we've got everybody who's at least written a little bit of code, done a little bit, had at least one sensor, putting it in a package that's tethered, so we know that's okay. If we lose a tethered balloon, then it's just not meant to be. I'll look at it that way. If the tethered balloon decides to unravel or go off or get disconnected, then we're not meant to get data, and the aliens are in charge. So from that perspective, I guess from a learning perspective, that part seems easier if we can find one, or find a group that can do again controlled altitude. We won't get as much high value data, but we'll get data that can actually be used to produce data analysis and show people how to make it all work and do that kind of thing.
I chime in, like we definitely don't want Princeton to be a governing vote here, but we've tried to do a wintertime tethered launch before, and the wind just takes it totally sideways. And it gets like no altitude because the wind just drags the
Blows
tether
it down.
totally horizontal. But that doesn't invalidate the value that you're proposing, which is it's an excuse to package up the whole platform, the whole batched platform, and prove that, the whole process gets proven just by, elevating it 3 feet. But we haven't found much ROI in terms of, reading off pressure changes and things that the X chips are actually interesting for, like monitoring the decrease in pressure during ascent and things like that. We haven't gotten anything out of a tethered launch, just because, especially in the winter when it's windy, it just goes totally sideways. But so Princeton's non-critical vote is we'd rather just risk our payloads to go big or go home.
Yeah, I kind of agree with Mike. The high altitude is going to give you the cold and the low pressure. It's hard to, and we have a pressure chamber here. We can simulate pressure, but to get the pressure and the cold, and to see if your electronics are going to overheat, even though it's -40, but you have essentially you're in a near vacuum. It does weird stuff to your electronics, and it's hard to simulate that with either a really expensive vacuum chamber or just launching them on a balloon and kind of rolling the dice to see what happens is versus just being a few thousand feet off the ground. It's cool. You can kind of package it up, but there's not a huge environmental difference at that height to really learn a whole lot about how your payload is going to survive a launch to orbit.
Judy,
Yes.
we
Mike, just chime me in. What's interesting, what I think I'm learning is actually I don't think the ISS payloads are ever going to see vacuum.
That's true. Yeah.
I thought they might see it on the cargo ride up in an evacuated portion of the capsule, but if you read into the NanoLab user's guide, it seems like they're in pressurized cargo hold through the whole ride, and of course in the ISS they're pressurized. So of course it would be really cool to show survivability of thermal survivability of the stack under a hard vacuum, at apogee of a balloon launch. Like that's just cool in and of itself, but I don't think it's a like necessary qualification for the ISS launch, but definitely cool.
we have flown our X chips on ISS before. So not with nanolabs, but with Space Tangle, and I have a massive data file from back then. So I could actually share that data file because then you have an idea about what the likely environment is. We have a temperature sensor that shows kind of like mid-30s most of the time. We have a CO2 and a VOC sensor that shows some interesting thing, but that was because it was in a container that also ran a biological experiment, so that produced some CO2. We had two accelerometers on board, and the one we recorded data and translated, and the other we recorded the raw data, and that showed like a G-force of 0.05 plus minus 0.01. Enough that we could actually use it. So Judy has shared a screen here. So this is the data we have over a month on the International Space Station, and you can see here that the way we looked at this thing, and we could see there's a kind of like temperature fluctuation between day and night or whatever period. They have 16-hour periods. They ran this thing here. But you can see the individual weeks, there's a slight difference. And then we have the accelerometer in the bottom graph here, where we can kind of like see that there's a low vibration and then a slightly higher vibration. So we have these kind of like raw data. Judy, if you scroll up a bit, this one here, I think that's the CO2 one, is it? I can't really see it. Yes, that's the CO2. So you can see that there's like a CO2 thing happening inside the container. Now, we are not at all in the same container as we were back then. So I'm not saying that we will get any of the same data. But the important part was more like temperature data and maybe humidity and other environmental data. My understanding is that, we fly in a box like this, which is a 3 millimeter aluminum profile. It have 3D printed end pieces that looks like this. So this is PLA that's printed and closed. There's no sealing, so it's just screwed in. It's kind of like very tight, but it's just screwed in. So I expect that the environment outside the box is going to be the same as the environment inside the box, at least after the first week or something like that. I do, however, not know. I know there's approximately 6 of these containers inside another container. And that other container, so we deliver this container to nanolabs, to nanoracks. They put it into a bigger container where where we share the space with 5 others. So we like 6 in this container here. And that container is packed on ground and sent up to ISS, and astronauts take this out of the cargo hall of whatever rocket goes up there, and then place it in a nanoracks chamber up there. That bigger container that can hold those 6, I have no clue if that's is hermetically sealed, and I, of course, don't know what's happening in the 5 other projects. We only know that when we kind of like scheduled to launch, and the rest of the others are scheduled to launch. So we might have an idea what they're doing in the other ones. So that's just a little bit about the environment. Mike, and I'm saying Mike, I mean Mike Galvin here. Do you have any better narrative about this than I have here? Or is that also your understanding?
I think there's environments specified in the NanoLab user's guide. So I think those are reliable. The only
Yes.
the little bug in my head, because I've never run the numbers, is we're a fully enclosed box, and how hot are things going to get with 10 to 15 boards all running at their, I'm sure nobody's going to be using all their power budget, but how hot are we going to get with all the boards running at once? So
Yeah.
my intuition is it's going to be a nothing burger. So like it'll be fine, but it's a little bug in my head about that.
Yeah, I think that's the reason why we probably went into the 30s there, because I do have a feeling that the temperature obviously is lower on ISS. It'll be too hot to work in, and so there's that kind of like maybe natural cooling from that. But anyhow, that's the environment. If you're interested, I can try to find the data file I have there that Julie showed, so the raw data file. Otherwise, we can download it from there, or you can download it yourself. We can send you the how to find the data on there, and then there's a way to download it into a comma separated file, so you can take the data you want to take if you're interested in seeing how it went there. But my understanding is that obviously when it flies to the ISS en route, whether it's cold or warm inside the rocket, it's our project's not on. It's only going to turn on once it's on ISS. So we're not going to be able to record any data other than on ISS. So that's just a little bit about the environment.
So what we had been thinking was that as an alternative to the high altitude balloon project, was that over the next 2 weeks, we brainstorm amongst ourselves and, with our students, different scenarios that we could contrive, or environments that we could have a look at, and then actually try our payloads in those types of environments. Maybe we feel, is it going to be exposed to a lot of cold? That means we can leave it in the fridge overnight. Or if we think that it is going to be exposed to more heat, maybe we put it in a greenhouse for a day or something like that. In a way to actually really start brainstorming what could those conditions be like, and then how could we actually create those conditions and actually run some tests. But Mike Wallach, if you're happy to do a launch, and if the participating teams are happy with that there is a possibility that the payloads aren't recovered, very happy. You know, great.
Yeah, like I said, we could do a launch. I mean, we could do a simple burst balloon where we're going to go up and burst around 100,000 feet and come down, and we can launch east of here so that we're kind of out in the rangeland of eastern Montana, where the likelihood of recovery is higher, the snowfall's a lot less. And like I said, of course, we can't guarantee we get it back, but we lose very few payloads, so I have a high confidence we can get everything back. So
Do you put one of those GPS spots on yours?
so our primary tracker is an Iridium tracker, so we use the Iridium satellite network.
Okay.
That is the spot is Iridium. Oh no,
Okay.
no, spot is Global Star.
Yeah, no,
Global
so
Star, yeah. Okay.
yeah, so Iridium's our primary. So we coordinate with with Salt Lake Center. That's our FAA, our closest center. So they track our flights and we coordinate throughout the flight, and then we use a spot as a backup tracker. So when we actually our tracking website is public, so everyone could see the balloon flight in real time during the launch. So if that's something that people are interested in, we can do that and coordinate having payloads sent here and a launch date and all that sort of stuff.
Okay, great.
I think a relevant question though is we've been talking about launching in the Nano Lab. Is that still the stance, or would Bjarke prefer to launch a skeletal thing?
Bjarke, sorry, you're muted.
Thanks. If we are launching, I wouldn't necessarily launch with an anorex container. You know, in reality, because the Nanorex container, I have a battery connectivity to on the ISS. If we fly on a balloon here, we don't have the same interface. So we have to create another interface for flying the projects on the balloon. And we have two different ways of doing that. But in reality, what we need to do, I mean, first of all, you know, on ISS, you are putting up a project that runs for months. It gets powered via the power supply on ISS. It's a 12-volt power supply we use on the ISS for this thing here. If we do the balloon, or like for example, what we did on the rocket launch today. So on the rocket launch today, we used the 18650 battery solution that we put in. When we did the Nano Lab launch, we used a power bank and a distributor. So each got powered by the PPU, so via one of these via these ones here. So we had 4 of these in parallel and then power banked it. So we might use this method here, or we might use, like a spine here. It's a prototype spine I'm working on right now, but a spine like that, and then connect it, and then use another power solution. So we just have to figure out how we do that. Obviously, we need to have power when we do this balloon flight, which is different from what we do with the ISS. So I wouldn't fly the same container simply because there's no it doesn't give any benefits. So I will fly a simile container, so I 3D print something that matches, and also like I'm not necessarily sure I will fly a full 2U height, depending on how many is interested in flying on the balloon launch. You might make a shorter version. But I think the best way of doing this thing here will be to do a container like that. And it might be, because that's what we did with the ISS HAP launch, we did a container that was wider than the 10 centimeter. So it was like And because we also wanted to have the power to withstand the temperature drop, we had like a 1 centimeter wall all the way around the battery compartments. So not, of course, around the chips themselves. So therefore, the overall container we did for the HAP, which will be the exact same situation, will be in here. We will fly with something that's like 12 by 16 centimeters, something, and like 14 centimeter high. So oversized 1U is what we flew with. And to make sure, and then we used hand warmers for keeping the power bank warm. It worked. It ran for 8 hours, so it worked for those projects that flew on the NASA HAP mission. I have a feeling that we need maybe something more serious regarding insulation if you fly from Montana. It's not the same weather in Montana as it is in New Mexico or Arizona at any given time. Especially because when we flew in New Mexico, it was in August and summer, and
and it was actually delayed because it was too warm. Yes.
And Montana here seems to be when it's the coldest. So there is some part there.
Yeah, so just a comment on a couple of things. So our payload boxes that we generally fly look something like this. The size and shape is to meet the FAA's density requirement. So as long as we don't exceed 6 pounds in a box this size, we're good. This has a harness that straps around it. So whatever the sizes that you're talking about are probably fine. And that could actually get housed integrated inside of this. And then this gets strapped and kind of tied into our payload string. As far as the cold, we actually don't heat anything on our payloads, at least for daytime flights. With the exception of a few things. Some of our batteries, if we generally fly a 3.7 volt lithium battery. We don't heat any of those. Overheating is more the issue because of the near vacuum. But on our night flight that we did, where we hit potentially negative 80 C on the way up, we were actually having some battery failures because of the cold. So heating the batteries is probably not such a bad thing. But the electronics themselves, we never heat. And our things like GoPro cameras, Insta360 cameras, they all overheat and shut down during the flights, even though it's 40, 50 below on the way up.
Yeah. So we only we don't do we haven't done any camera, but we only insulate and heat the battery. The rest of the X chips are all in free. I mean, that's the whole purpose, is that they get as much access to the atmosphere that it can. So it's only the battery I'm concerned about. As I said last time, we had a polystyrene printed box, PLA printed, 3D printed with 1 centimeter wall, and then inside there I had room for 2 hand warmers, and that worked. I mean, they have to be, of course, in a physical connection with the battery, because there is no atmosphere to kind of like heat anything forward and backwards. But hey, that part of the project worked fine. So let's see. Okay, but I think, Judy, maybe we should just take all these comments about the flight until consideration, and then make a plan and then come back to the team here.
Absolutely. And also let's give Mike and Gino a chance to sleep on it and come back and say, are we regretting having volunteered this?
No, yeah,
You never know.
I don't know.
Anyway.
It's the parachute, our tracking system in the balloon. We fly much more complicated payload strings typically, so this would be relatively easy. The biggest thing here is the jet stream and the stratospheric winds all push east in the winter time. In the summertime, we get it turned back, so we go east and then we turn back in the stratosphere. It just means we go a little bit further. So launch logistics are a little more complicated just because we travel a little further, but definitely doable. It's a big state, so we can travel a pretty long way and still be in Montana.
No crossing any
And I have,
borders.
oh,
Yeah.
sorry. I have a
Carry on.
couple questions about the boards themselves. So as I've been kind of going through the little breakout like breadboard, I noticed on the Fusion design, are there? So I know on the top pad like contacts, you have the I squared C lines, ground, power, and I forget the last one. But the on the bottom sides of the boards, are those one second, I've got the design in front of me here. Are they different pins on the bottom side?
Judy, I'm gonna share my screen.
Yep.
Yeah, and he's talking about these edge connector pins at the top and
Yeah, no,
bottom.
I get that.
Yeah.
So if you we have the pins documented here. If you go to domino4.com here, so GitHub domino4.com, then under this top screen here, there's something called technology, or you can just obviously write domino4.com technology here. So here you can see the pin numbers, how it is. So we call it north, east, west, south, and then there's a bottom and a top of these X chips. And so pin 1 to 5 on the top and 6 to 10 on the bottom. And this is the pins. So 1 and 2 is I square C. Then you have 3 is ground. 4 is 3.3 volts. And then the last one is V source, which is power from the original source. But that means is that if we powered using one of these PPUs here, it gets the 5 volt in here, then there will be 5 volt on V source. So it's not like anything you should necessarily rely on, but there is 5 volt for that purpose. When we put when it's going on ISS, there will be no power on the V source. There will only be the 3.3 volts. And then there is on the bottom side here, we have reset and proc. So this is pins that's being used on this thing here to put the chip into programming mode if you program it using this one here. Now, you guys are not used to the old chips where everything was programmed via this thing here. The new one, you can program over USB, and therefore this reset and proc pins are not really used anymore. But on this one, together with the RX and TX, these 4 pins from I6, 7, 8, and 9 was used to program the core with in the old system. You can still use the pins, so RX and TX you can still use. They're connected to RX and TX on your board. And I'm coming back to where you find those pins on the chipsets. So if you, for example, have like your own GPS and you don't want to use I2C because your GPS might not run I2C, but typically run on a serial port, then you could connect it to RX and TX here. And then we have one I/O pin that used to be used for something else, but today it's an I/O pin you can use as an I/O pin. And there's a little bit of sorry.
Oh, sorry. I just
Yeah. So that's then there is this is the pins on when you get the extended core. So I'm gonna show that just now, but the extended core is this core here. It has like a bus out here, and if you want to know more about how that is, what's there, then you can see the pins for the extended core here. So this is these end pins here, and they are the same on both sides. Not like mirrored, but like you can flip it around. So this pin up here is the same as this pin here, in both ends. So there's 4 times redundancy on this thing here. So when we put this into to the ISS, you get power from these pins here. And there's the communication we're going to do is going to be over the CAN bus. I'm coming back to that. But everything happens over these pins here. Now, you are only able to use those that's called external on this board here. So there's only these. There's of course there's power VCC and there's ground, but then there's the CAN bus here that can be communicated over. And I'm coming back to the CAN bus, so I wouldn't worry about that right now. The rest of these pins are not connected for you on the spine that we're using to stack everyone. And then the extension slots are on the board. So there's this extension slot here. And this is the pinout for these extension slots. So, for example, I have a lower radio that looks like this thing here. I don't know if you can see. Yeah, here we go. So here's the lower radio. And those 10 pins that side is the same as the 10 pins on the other side. Again, they can just be flipped around, so you can mount it inside this thing here. Or like, for example, with the SD card, the same SD card that you have on your little core you have now, that one you can also flip it around and have it upside down. Again, it's just to have redundancy and that nothing actually goes wrong if you mount it the wrong way around. So that's the pinout. There is a change on the pinout here, and that's this pin number 7, which actually is not like that anymore. It's been made to an extra GPIO pin. So there is like 3 GPIO pins. So you have SPI to communicate SPI. You also have I2C. You have your VCC and ground, and then you have 3 GPIO pins. So that's little bit about the pins there. Do you know this? Does that answer your question?
Yeah, that does. Thank you. And then I had one other kind of quick question. I have never worked with so many I2C devices at the same time before. And I've seen some stuff just kind of through my own research that for having these longer I2C lines, it's recommended to add some like resistors in series along it. Do you have any things that you kind of did for the board since you have these long kind of gaps?
So I did an experiment, it's a number of years ago, where I connected 39 devices, I2C device, 39 of our chips here, 39 different, more than 39 addresses, because some of them had several connection problems. But I connected 39 in like a web of like, 6x4 or something like that, maybe more, 8x4. Chips I put together, and I connected to a Raspberry Pi to see if I could, communicate with all of them, and I could. So the way to say it is that I haven't actually been in a situation where I had to do any kind of boosting the signal for I2C. It's basically not within 10 by 10 centimeter. I think you have no problem, and if you can put 10 devices on this thing here, then it's not going to be a problem. I haven't, I never had a problem with it. I would say that, I can imagine it depends on how fast you want to read the sensors. So some of the sensors, I2C sensors, so the standard speed is 100 kilohertz, 100 kilobit per second. And then there's various modes. The next one up is 400, and that's 100 and 400 is what most of them runs. Then there is a speed that's slightly higher. That's it's not slightly higher. I think it's a 1 megabit. and then there's 3.2, and then there's I think 5.4. So they're like much faster. But I don't think any of our chips runs any of these speeds. I think maybe some of them run 1 megabit. And again, the problem with these speeds are that some is actually I2C approved, so Philips standard I2C. Other is the SM-BOSS speed, so 100 kilohertz is actually a SM-BOSS speed. So there's a lot of confusion around this thing about I2C because it's not necessarily a I mean, it's a very, very old BOSS, and a number of providers, like for example, Arduino, they don't necessarily say I2C, they call it two-wire interface to kind of like avoid being in licensing issues with using the I2C, and at the same time, and not necessarily then guaranteeing the one speed, the other speed. So this thing here with putting any resistors in order to so we don't have to, do anything extra. We can just connect things straight, and that always worked for us.
Gotcha. Well, thank you very much for the help.
Great.
Are there any other questions? I wanted to share the schedule, if that's okay. Apologies. Also, while Bianca was answering that second question, my Zoom rebooted again, so I think there may be a big gap in the recording. Very strange. I think it's possibly my internet connection, this hotel where I am. I think maybe the wind's interfering with the smoke signal. Right. Here we go. Right. So as you'll see, what I had done is I had actually changed this, but we are obviously now reconsidering this. Is that what I'd done is that in purple, in this pinky purple, I'd actually put in here that, we change this to testing sensors and code in 3 different conditions for up to, like 3 days each, something like that. But what we'll do is over the next few days, let's have an open discussion on this, and let's probably change that back. So what I have done is I've put in dates for workshop 3 here, which is December 17th and December 18th. So that what we can do is we can make sure that we keep up this cadence of meeting once a fortnight, because it seems to be working quite well. Yeah, so what we'll do is let's actually discuss if we do decide to reconsider and do the high altitude balloon launch, let's just have a look at like when that would suit you, and a bit of a schedule around that. And the reason for that is that our next big milestone, let me share again. We had this decision point here where what we need is we need you to be able to make a decision by end of January to let us know if you're going to be able to ship your payload by March 15th. So that's really to an extent, that's kind of like a go, no go decision, is that we need those payloads to be shipped by 15th of March. Otherwise, we're gonna miss the deadlines. So that really is that decision point there. So what we were looking at is if you could have a very good idea that you'd be ready, to make that decision end of January. Are you going to be ready 6 months later, or if you think maybe you're not going to be ready? Is there anyone who's concerned about those deadlines or those timelines?
I'm not concerned about the timelines, but my team is definitely a little behind. It's only because I don't think it fits. Maybe this doesn't fit in this format of the workshop because we're all at different levels with the project. But I do need maybe some offline training on. I was having difficulty getting the advanced electronics to work with the Arduino code. I also maybe want some sort of lesson with the Discord since I haven't gotten the ISS invitation, or maybe I've missed it. So maybe if there could be some other offline workshop with that. My students have designed things for rocket, NASA Tech Rise rocket, and 2 weather balloon projects. So they have the capabilities. I just want to make sure that I know we can make the deadline, but I just want to make sure I'm caught up with the other teams here that are on the call.
Great. Susan, we can certainly do that. Let you and I touch base, and yeah, let's make sure we can do that. Amanda, how are you doing?
We're going. I'm coming off of a trip to China, and the teacher sponsor just had twins. His wife just had twins. So we've been a little busy, but we're hitting the ground running this week. I think we're probably the most behind because we had some Wi-Fi connectivity issues with trying to get district to give us the passcode so we could even connect the devices on the kids' computer, and we had to do some software updates. So that kind of put us in a little bit of a delay with getting the sensors to read to everything. But I think it might be beneficial. I would hate for us to keep going and be going in the wrong direction and just don't know what we don't know. So it might be beneficial for us to have a little bit of a work session, hopefully with someone, just to make sure we're on the right track and that the finished product for the high altitude balloon launch, I'm still not super clear as far as exactly what that needs to look like and be able to do to be able to hit that deadline. So anyway, I don't want to waste time asking more simple questions because I know there's people with a lot more advanced skills here that are doing some other things. We're just trying to get the basic thing to work. So,
I feel like everybody on these workshops needs to get comfortable with y'all are the real customers. We're off ahead doing crazy stuff that these kits are not real. The kit and the curriculum are not really for. We should not be monopolizing these workshops. Y'all should take the priority in just getting up to cruising altitude. And yeah, I think we need to prioritize getting everybody to just get the chips reading data. And if anybody that wants to write like even writing your own Arduino code is really not necessary. With these kits, you can prepare a balloon launch and an ISS payload without ever writing a line of Arduino code. But if anybody wants to write Arduino code, that should be the priority in these workshops before Mike and I start talking about custom payloads, balloon launches, etc. So that's just a way of saying, please don't feel like you're wasting our time. We are wasting your time.
Yeah. It's basically because, Amanda, you have to understand, Mike, he will just pick up the phone and call us day and night anyhow. So he has absolutely no problem or writing very long emails. So what he says is that you're absolutely welcome. So what I actually want to do is that I just want to add. I just want to, especially because it's recorded, so you will be able to see this thing here. So I just want to give a very slightly introduction into what's required or not necessarily required, as Mike says, because we have students. We have a teacher from fourth grader, and she's been on most of our missions, and she never wrote a line of code. Okay, but she still want to be with and have the kids excited about it and things like that. So I just want to say that there's a very low bar to join this thing here. So I want to show just what the requirements are, and when I say requirements, it's like you do it or you get one of us to do it. So it's absolutely it's absolutely possible for you to make the deadlines. But and I think if I can just use like 15 minutes going through some of these things here, then you will see that it's not necessarily so difficult. And I also just want to say that even the programming here, I mean, Mike, even though that do dedicated payload and things like that, getting the first piece of code still take Mike and Mike's students some time to get it up and running. So it's not necessary, and it can be the smallest little thing that makes it that's going to make it. Trying to find a bug in software can sometimes be very difficult. So I'm going to share my screen, and what I'm going to start with is actually, before I share my screen, I'm just going to show you the different components, so the hardware here. So this one here is the core that you should have been familiar with already. So that's the one that arrives with. And with that comes a little SD card holder. And so you have that there, and you have the SD cards that goes into it like that. So that's the core. Now, when you fly on an ISS mission, you're not going to use this core. But all the software you're going to use on the core you're getting works equally on this thing here. So this SD card slot, I'm taking it out. And then instead of that, you're getting a core that looks like this. It's probably white, I can't remember. But it's like this thing here. And this expansion port that we have there, you also have that there. Those two buttons that sits there, these two buttons are sitting there. There's two LEDs around here. They're also around there. And the only thing that's moved a little bit around is this USB slot here that's moved up here. But this one here also have an extra SD card. So while you can still use the SD card like this and plug it into the side here, that will work. If you got it to work on this, that will on this core here, then that will work on this core here also. But there is also a SD card slot here in the sides, and that's the SD card that let me see here. I'll find an SD card I can slot in. So there is the SD card slot here, and that is the SD card that you should primarily use. Okay. Now, there's no reason why you can't use this SD card other than this SD card, it sits flush with this line here. So when it goes into the nanorex, when we put it into like a thing like this thing here, and it goes into a container. So when it goes into a container here, it's sorry, let me just put it right. So when it goes into a container like here, it sits down here at the SD card, and it can't get out because it's inside this container here. So that's That's the SD card. And then, of course, once you kind of like are familiar with this thing here, you now have the opportunity to put different sensors on. So here's 2 sensors, and you put these 2 sensors on. You already have some of the sensors. You can use sensors like that. And you have the opportunity to put up, and you can put 2 more on. Now, what Mike and Mike are doing, maybe it's in the name, they are using a board like this thing here. So this is a prototype board, and that allows them to put bigger sensor and other sensors in. So they can put more sensor in. They can take the space that's allocated and squeeze much more into the same little board here. So they will use a board like that, but you guys don't have to use it. That is, and what I think Mike Wallace is doing from Montana is that they might actually do a board like from scratch. So the components directly on the board. This board here is ready where you can buy other sensors from like SparkFun or Adafruit, and you can solder them straight into this board here. It has standard 0.1 inch pitch between the holes. So, if you get like a sensor from SparkFun or Adafruit, you can put it in. But of course, there's also the possibility of doing this thing here completely your own board, which Mike from Montana might do. I'm not sure what they're doing at from Princeton. I have a feeling they are putting the SparkFun sensor straight on the board here, the breakout boards. Now, you can also buy sensors from Adafruit and SparkFun if you want some other sensors. So we have one here, and that sits on a prototype board where you simply just get a cable. It's cable like this little cable here, and then you simply just click it into the one another. It have a standard 1 millimeter pitch, and I'm going to show you a web page about this thing here if you want to prototype your own one. This is the easiest one to prototype your own board. We have other prototype boards, but I'm not want to confuse it in this session here. But this one here is the one where there's no soldering still. You can take a third-party sensor, sorry, getting focus here, and then you can simply screw that in, bolt that in, and then you have your own. And you could have 4 of these ones here. Okay, so that was just to demonstrate the hardware. What I want to do now is I want to first share some pages here. So let me just go and say share the screen here. So you should be able to see the screen. So over here I have my browser here, and if you go to dominio4.com/CWA, as the CWA, that's the name of this chip here. And this one here we call CWN, but I haven't made a page for it yet. If you look at CWA version 2, you have all the kind of like pins that we can talk about here. So when I before talked to Gino about some of the pins, for example, on the expansion port, I mentioned that there was like a third pin that was now was a GPIO. That's kind of like documented here. So the different pins are documented here. Anyhow, I want to show this thing here just so you know where you find the pins. For this board here, the only pin that's not documented on this pin here is iron number 3, but it's documented somewhere else. I'm going to show you that. And that is the chip select for this SD card. So that's the only pin I just haven't documented on this board here. So, but I'm going to show that to you now. So that's where you'll find the information about the chip here. If you want to do this expansion board, sorry, not this prototype board with a wire, that's called the MQC interface. So if you go to domino4.com/MQC, you will see here these two pictures of these boards. And there's a little bit of a documentation about how it works and how you can use SparkFun's Quick or Adafruit Stemma QT chips to kind of like connect to it. So if you have sensors that you want to use that we don't have, then you can actually interface it like that. So there is a little write-up here. It's not very long. So I suggest if you kind of like want to go down that route, you can see here I have two Adafruit boards. The one is a pressure sensor and another temperature and humidity. Not that it's needed, but that was just some I had lying around. So I mounted for demonstration purpose here. So that's the prototype part. Then what I want to do is I just want to talk a little bit about Arduino here. And when you program before I do that, I want to just the last page here. So on the GitHub also, domino4.com, we have this example-sd, okay? So if you go to domino4.com, example-sd, this is two files that reads two sensors, in this case IWA, which is the weather sensor. The weather sensor, which I don't have here on the surface, and what's the other one? This accelerometer. So this is the accelerometer, okay? The one with the rocket here. And it's difficult to see, but it's actually with small letters here on the back. It will say down here in the corner something domino4.com/IIA. Anyhow, so this is just an example of reading two sensors. And here's all the different documentation about how you program it and how you get all this thing here up and running. And here I have documented this SD card chip. So all the pins for CWA as I write is documented here. But for CWF5, there is a list of the pins missing. And the one that's important here is this chip select. So here is how to use all this. So the programs, there's two programs. There's one for using the expansion port. So that's the one that you can try out directly. So this is one Arduino sketch, as a program is called in Arduino. So here I have defined a data file. The I2C pins are defined here. And this is the way I talk to the SD cards. When I use the expansion port, I use a 4-bit MMC connection, as it's called. These are the libraries that's been used. And then I instantiate the two libraries. It's explained in the documentation how you install those. And then there's a setup where I initiate the two sensors and I initialize the SD cards. And then I have this loop here that runs around, read the one sensor, read the other sensor, and write it to the SD card. So that's if you run this program and put those two sensors together, you have what's needed for the ISS mission. That's what's needed. It's nothing more than just reading the sensor data and write them to SD card. So one of the things you could do is that you can find a weather sensor and an accelerometer. I don't know if you have those two. Doesn't matter. Even if you only have the weather sensor, it will still work. So if you have the weather sensor, you can plug that in, try to program this thing here, and you will feel you have your hello world, as it's called in this computing world here. You have like a whole through. You kind of like know you can program it, you can get it to work and write to the SD card and all that kind of stuff. So this is a way to get going, this one here. So if I go back to the documentation here, it says here there's these two projects demonstrated, the built-in and the one using expansion port. It talks about how to set it into programming mode and bootloader mode, and how to use to get it up and running. There's a little bit about how to debug it if you don't get it right, and then a little bit about the SD card, making sure you have a proper formatted maximum 32 gigabyte SD card. So do yourself a favor, read the troubleshooting here up front, just to make sure you kind of like have everything. And with that, I'm just gonna show in Arduino here. So in Arduino, what you have to do is that you have to install
Sorry, Bianca.
ESP32.
Sorry.
Yes.
Sorry, Bianca. Sorry. I just need you to pause. Sorry. You're going very fast. I want to come to a question that Amanda had in the chat.
Go for it.
If we are not writing anything custom in Arduino and we're using the basic sensors, will we use Kibana to view data? Or do we need it to connect with the Arduino program? So that was in response to me saying that what I wrote here was that the objective is to collect data using the sensors and to write that data to the SD card. After 4 to 6 weeks, we receive the boards back from the ISS and the data collected is analyzed. If you wish to, you may use the code that Bianca has developed for your experiment if you feel that you're running out of time. So I want to bring it all the way back to vanilla X chips. Very simple, collecting data, writing it to the SD card, and then what happens to that? Back to Mike Galvin's point is we're talking about prototyping and this and that and the next thing. Please, I just want to bring it back to the raw objective of ISS collecting data, analyzing it afterwards. So,
well, and maybe this will.
Yeah. Sorry,
maybe
Amanda.
This will
you
help
carry on.
figure out where we are. So I have this, and we have the sensors. It's working. I can get it. I can connect it into my computer. I can see the data in Kibana, right? Where we're stuck is when I put an SD card in here and it writes it to the SD card, does it write it automatically? And then I can just pull the data straight from the SD card. Or is there something else I need to do to make it write the data to the SD card? Does that make sense?
Yeah. So first of all, what you have there is, of course, our starter kit, and if you put an SD card in there, as I mentioned before, at maximum 32 gigabyte SD cards, and you have to format it or make sure you take one fresh out of the packets. Any SD card fresh out of packets will just work. If you put that in and run it, you can at any given time unplug it and plug it into your computer, and you will have what's called a comma separate file. If you double click on that file, it will open up in Excel. If you want to have Excel installed, it will open up in Numbers. If you're on a Mac and have that installed, or you can open up in Google Sheets or whatever. So you can open the file directly and work on it directly. And obviously, once you have it into Excel, you can do whatever, or any of the other spreadsheet program, you can do whatever analysis that you're familiar with there. So the data, so that's how it is with the kit you have in your hand. There's no difference from the kit on ISS, except that you have to wait for it to come back from ISS. So once it comes back from ISS, you get your project back with the SD card in, and you can then take the SD card out, and you maybe have many megabytes of data, because you will have maybe a month's worth of data, recorded down maybe every second to the SD card. 32 gigabyte for data is quite a lot. For a 4K movie, it's not a lot, but for what you are going to record on this thing here, it'll be surprising if you get to 1 gigabyte. So you will have ample data to record, and you will then have that as one big file. Now, when I say one big file, it's because that actually depends on what you choose. in your software, because you are able to say, listen, every 24 hours, I close the file and I make a new file. I give it a new sequence number. So, I don't have one big file. I will have one for every day, So there's a possibility of having, you have the possibility of having two SD cards. So you can say, well, I'm writing to both SD cards just to make sure I'm not losing any data. SD cards, SD card, like it in the camera, that's also the same thing. You don't want to risk losing your data. So there is opportunities to do whatever. The program I demonstrated and the program that runs on the things you have in your hand writes a comma-separated file, but you can write any kind of format you want to. So if you are familiar with another format that you find better for what you're doing, so it could be a XML format, or it could be a JSON format, or it could be some binary format that you're familiar with, then you are absolutely welcome to write, of course, any other format. Comma separate file has been like around for a million years, and literally since the dinosaurs, I think. And it's you're open with any spreadsheet. So that's the reason why I normally show that. The problem with a comma separate file is that you only have like one line for all your data at a time. So if you have some data you read more often than others, you tend to copy the data. So for example, if you read the temperature and acceleration, the temperature you might only need to read like once every minute or 10 minutes or whatever, but acceleration you might want to read every 20 milliseconds. So then you can do either write a record every 20 milliseconds and just read the temperature all the time, even if you don't need it. That will give you a lot of wasted data. Or you maybe do two different comma separate files, one with your one sensor and one with another sensor. But all that is, as I say, is just extra. Once you get to write a comma separate file and you get the idea about it and you kind of like start playing around with it, then you might find that, okay, let's do it this way. Or you can do the simple one, just one file, as I have in the examples here. Really?
Amanda, did that help?
Yes, it did. Thank you.
Did it clear some of the mist?
Yes. We just need to get some SD cards and test it out, and
Okay.
but yes, thank you.
Okay, fantastic. And there's a fantastic chat and lots of offers of lots of different things. So I'm going to be following up on this with everyone and then sharing that with everybody likewise. So that is terrific. Do we have any other questions to cover for this session? I can see that Mike Galvin has given his apologies. He needed to drop off as well as Ifriki. Susan, anything from your side apart from us setting up something with you?
No, you've given me some information. I could proceed, but I think I will set up an offline conversation just to make sure that I'm supporting my students as they go through. They've picked out the sensors. They haven't tested. They're going to select a few sensors, but they've selected about maybe 7 or 8 they want to test and evaluate for the project. So that's part of the reason why we'd already scheduled something with Blue Hills Observatory, just so they could do some remotes to narrow it down in scope. But yeah, no, this was a very good conversation. I think I just need a little more support offline. So
Great.
Thank you.
Fantastic. We'll make sure of that. Okay, good. Alex, Mike, anything on your side?
No, a lot of mine now is we've got the basics down. I've got the kids working through. I'm trying to put the documentation together for the kids to do the coding, because I had recognized, like Bjork had said, we don't need to get temperature constantly when it's never going to change. So it's, although I had it for the rocket code, I want them to start thinking about inputs, outputs, and those pieces. We may get crazy and look at some plug-in sensors now that I know that they're just the spark funds will just plug in and be simple. But yeah, but I'm gonna put together the videos. So once I have those videos, I will share them and get them to you so we can put them or put links to them in the Discord or otherwise and get them on Canvas so that people can do. But yeah, my biggest challenge was the steps that Mike actually followed through of getting the board to communicate with the PC. Once I got that, I had the code working, and then it came down to a formatting issue, which was my last bit of problem. But for outputting the data. So yeah, that was the last bit. So, but I'm gonna write it all down so that my goal is that we have a really, really good set of instructions for people, as you know, because I'm looking at it right now. I've got seniors, juniors, and sophomores. So by the time we launch, the seniors will have gone and will be coming back to do stuff, and I'll have to onboard a whole nother group, a whole additional group. So
yeah, and we're all doing this with the Nano Lab for the first time. So yeah, we're getting there, you know.
oh, absolutely.
We're falling forward together. That's cool.
Yes.
Yeah. Mike, from your side.
No, I think we're pretty good. Our big hump was again, kind of like Alex, just trying to figure out how to connect to that board through Arduino. So I kind of posted the instructions. One of my actually it was Gino that sat there and figured out how to do it. And then he showed me. I did it a couple times and just kind of wrote the steps down. And I shared that out in the chat, just for the groups that are trying to write their own code. Because once we got over that hump, then it was familiar ground for us. There's just some unique things with some unique things with that chip that we haven't used before. So took a little while to kind of figure those things out.
Yeah, fantastic.
If I can just add to Mike, to your thing here, not that it's important because everything you have here is sufficient. The difference between these two boards is also, and you might not need it, is this one here also have PS RAM. So in the Arduino, in the dropdown, where you say, for example, go to tools, USB CDC on boot, there is also an option where you can enable PS RAM. So if you enable PS RAM there, you will have access to 8 megabytes more PS RAM. It's very unlikely that you're gonna need it. But if you kind of like consider doing some onboard interference, that's not the right word. Is it? If you're gonna do some calculation on board before you store the data, you might want to have more RAM available. So there's
inference.
8 megabytes.
I think the term is inference.
Inference. If you want to do some onboard inference before you store the data, there's 8 megabytes more RAM on this thing here. So that's the only thing I just want to add to your little explanation. But again, it might be just confusing more than anything else. What you have there is spot on.
Yeah, and then we can connect again offline on the balloon flight. I'll meet with our directors here, I think tomorrow, just kind of run it all by them and logistics and that sort of thing. So, but we'll connect and see.
Fantastic. Thank you.
Yep.
Terrific. Great. Gino, are you okay? You're good.
Oh, yep. Yeah. Thank you very much for the help.
That's great. Absolutely. Susan, thank you as well so much. You and I are also going to touch base offline. So that's 100%. Thank you, everyone. This has been really great.